Hello, my name is Mykhailo Korbakov, and today I will talk about my company's reflection on Blazor technology, and of course about my own perspective on it. Blazor is a relatively new player on the technological landscape, but Microsoft is pretty clear that they are very serious about it. Everything points out that Blazor will become a consolidated solution for UI on multiple platforms. On the web, on mobile, on desktop, and most probably will yet to see other platforms. This will not be a talk about Blazor itself. I'm assuming that everyone here already knows something about Blazor, and I'm more interested to hear something about real practical consequences of choosing it in your project. So let me share some first-hand experience with it, both from technical and from business standpoints. So, why talk about it? What are the reasons to be interested in Blazor other than Microsoft's marketing push and evangelism? The main reason is that Blazor offering something new to developers, especially for web developers. I would even dare to say that Blazor brings to the web the development models most often seen in enterprise desktop applications. Many people may have not so happy memories of developing such applications, and definitely rightfully so. But there is still a pool of valuable approaches there, and Blazor offers a modernized take on them. Most importantly, this something new is not just a nice new thing for engineers to play, but also a technical enabler for some applications. Also, in some situations, utilizing Blazor can make a whole difference for a business idea to be considered feasible or not. As one may expect, great power comes with great responsibility. Every architecture and technology is an enabler on one front and a constrainer on another. It's essential to understand the constraints that Blazor is imposing before deciding to use it. Today we will discuss some of these constraints. And many architectural decisions have consequences reaching up to business processes surrounding development. Adopting Blazor removes some familiar steps like REST API design, but puts extra importance on other steps. For example, engineers onboarding. Every experience is framed by some context, and the biggest part of that context is the person behind that experience. So who am I to make such bold statements as on the slide before? I've worked in IT for whole my life. That makes up for more than 20 years of experience. During that time, I worked with all different sorts of technologies, from mainstream Java, .NET, Python to Haskell and assembly. Most projects I worked were web-based. Other projects were much more diverse, ranging from high-performance computing to automatic bidding platforms. I lived in different countries significant part of my life. I have worked in different environments, from academic research to standalone IT consulting. Half-jokingly, I had no chance not to become very open-minded and welcoming of new ideas like the ones Blazor provides. I spent the last 10 years in different sorts of IT management positions. That thoughtfully shaped my view on technologies. I see them as a business potential first and an engineering marvel only second. That will seriously influence my talk. To put it in other words, I have very little interest in the development and technologies in vacuum. My goal is to build products and bring value to people. So, speaking of products, another essential part of the context around experience is the project. The project in focus is called Quantum PM, and we boldly want to disturb the project management software market. You have not come here for a marketing pitch, so I will not talk much about how awesome we are. What's important here We believe that very few people are delighted by their project management software. Most relevant products are promising to solve the planning and management hassle. But in fact, very few go beyond the structured registry of tasks with a reporting engine on top of it. And everyone who has been in the trenches of managing a software project knows that it leaves too much for hand and guessworking. There is definitely a fruit up there, but not the low-hanging one. To break out of the red ocean of competing products, we want to provide unparalleled support for automation and decision-making. There is a saying, if you want to have something that you never had, you will have to do something that you never did. So from the very start of the project, we wanted to search for an unfair advantage, something that will improve our productivity on mundane tasks so much that our small team will have enough capacity to think about things that matter, that really provides value to the customers. Now, with all the scenery set up, I can proceed to decisions, actions, and consequences. In December 2020, we needed to make the architectural decision about which technology would be a foundation for our product. The technological landscape was slightly different back then, but not too much. Most importantly, the actual .NET version was 5, which is non-long-term support. We had to make a little bet here. The criteria for the decision were purely business-driven. First of all, we wanted to have a mature stack at our disposal. The necessity to spend time on plumbing like logging, telemetry, integrations, and so on hinders startups. And to survive, startups must be very efficient per dollar spent. Also, widely adopted platforms have a great pool of conventional approaches to solve typical problems. That makes onboarding juniors much more convenient and straightforward. And I am specifically talking about it because the ability to efficiently use junior developers is also vital for any startup not sitting on a pile of venture money. With that in mind, we narrowed our options to either Java or .NET. Now, we have to admit it, developing high-quality SaaS applications with rich UI is complex. We can grumble as much as we want about how difficult it is to hire skilled front-end JavaScript developers, but this is the reality of the job market, and we cannot do much about it. Every person responsible for a development team build-up can share their own sad stories regarding it. These stories are great for a beer time with friends, but from a business development perspective, I would rather avoid them altogether. It's better to have a dull boy reputation with no too fun stories to tell, but with a successful product, than otherwise. For a final point, we assumed that the product would require a complex backend processing with data that are actively changed and viewed by users. That sort of processing is more straightforward in the stateful application with shared data readily available in memory. Given our unwillingness to introduce JavaScript to our stack, that led us to the live view architecture. I will cover the live view approach a bit later in the talk, but what is important here is that available live view implementations are very limited. While there are at least some for every popular language, with our limitation of Java or .NET, we were at quite a restricted choice. It's either Vaadin framework in Java realm or Blazor server in .NET. Everything else is far from maturity. It's usually very easy to choose when it's just two alternatives. We had to add just two considerations to make a final decision. First of all, the supporting powers behind Vaadin and Blazor are of entirely different scales. Vaadin is a successful and well-adopted framework in the Java world, but from a small business perspective, it is much safer to ride on the waves that Microsoft is pushing with Blazor. And the last but not least, another job market reality is that, on average, it costs less to build a .NET team than a size equivalent Java team. We may not like it, but pretending that it's not a factor is unfair. To yourself at best, and to business owners at worst. In different discussions over the internet, I have seen claims that Blazor is unique in its architecture. That's not true at all. Both Blazor WebAssembly and Blazor Server are based on already well-established architecture. The WebAssembly flavor of Blazor is very impressive to learn about. But other than the change in tech stack composition, it's still the same well-known back-end front-end HTTP API architecture that we all very well familiar with all its positives and negatives. I will not talk further about WebAssembly because our project experience is tied to another flavor. Blazor Server is a different beast and indeed may seem like something completely new. However, the same concept has been around since at least 2014, when the first version of the Phoenix framework for the Elixir language was released. Pretty exotic, right? I also believe that I saw the same idea before, just not at the scale of a complete application. Digging even further, we can find that the same approach was used in X window system in Unix likes. But don't worry, I will stop my cosplay of digital Indiana Jones here. Anyway, Phoenix authors called the architecture live view, and the term stuck. Since then, it's been implemented on various platforms, reaching far away from the original barely no Elixir. With Blazor Server, it comes to .NET world. So let's make a refresher about what this live view is about. There are two essential features of this approach. First, the pages are fully rendered on the backend. This rendering is a first-grade citizen, not something like server-side pre-rendering for React or Angular frameworks. But what makes it different compared to good old PHP and Perl applications that delivered full page on every request? It's a second feature. Updates are served from the server to a browser as DOM diffs, and the browser runs the JavaScript runtime, whose responsibility is to merge these diffs and update a view smoothly. The specific way how these updates are pushed to the browser is not so important, but in practice WebSockets are the most adopted way. Taken to the extreme, the combination of these two features eliminate any need to run any JavaScript on the front end, besides frameworks applied. As one may expect, making a DOM div on the backend requires maintaining a rich state for every browser session. In other words, the backend must know precisely what a user has in his browser. With Blazor Server, this consideration leads to stateful application with long-living WebSocket connections to the backend. And maybe you have seen it coming. This is dreaded sticky sessions in action. Naturally, in general, sticky sessions and stateful web applications got quite a bad reputation over the past decade. Part of it is rightfully earned. Some quality attributes, like fault tolerance or scalability, are considerably more challenging to maintain with stateful applications compared to stateless. Another part, however, is based on the rise of internet-scale applications that were only achievable with horizontal scaling and statelessness. This hype around it was so absurdly high that at some moment every small startup was planning for a high load. But realistically speaking, with modern hardware and clouds, it's totally possible to run a successful business without hundreds of servers. You probably cannot build another Instagram or TikTok in the live view way. Still, as long as revenue per user is measured in dollars, not fractions of a cent, stateful architecture cannot be dismissed purely on a bad reputation basis. And these dollars, not cents ballpark, describe a very large share of subscription-based SaaS applications. Now, as I talk enough about our decisions, it's time to move to consequences. Theorizing in a vacuum is fun and safe, but practice is the criterion of truth. The first and the most visible result of choosing Blazor was really simple team composition. We did not need to hire back-end and front-end developers and balance their tasks. We did not need to search for half-mythical full-stack developers. Every hired C# developer is full-stack automatically. Front-end development is complicated, but modern HTML and CSS alone? No. Even junior developers with no experience catch up quickly with minimal guidance. And naturally, a single developer can implement a full feature without coordinating between the backend and frontend. That eliminates the whole step of designing REST API and is a significant effort saver. While designing API may not seem like a big hassle, we are quite used to it as developers, it's still a mostly coordination task and not technical, and coordination is always time-consuming. So, next. With stateful application, we can afford the luxury of keeping the entire tenant state in memory. When any tenant's user logs in, we load all of its data in memory. As long as all tenant's users stick to the same server, we can share all data between them. That saves us database round trips on every read and makes any updates made by a user immediately visible to any other users in his team with zero extra code. Of course, sharing data between parallel user sessions requires careful planning for concurrency. That's not a problem in our domain, because concurrent updates to the same entities must be avoided from the business logic standpoint. However, concurrency over shared data may be a real pain for other applications, so please avoid taking our experience here as a general recommendation. With Blazor server model, we can use the full power of the .NET platform while implementing UI. Crossing the boundary between backend and frontend in the traditional REST API applications always require extra work. Cross-technology API is always the lowest common denominator. But within a single platform, we can use powerful features like events, delegates, generics, and so on without any additional efforts. It took us some time to wrap our hands around it, but now we are actively using these features in UI code and are very happy with it. It's a huge time saver. Another vital point is testing. With browsers, end-to-end testing is cumbersome. Even the most modern tools in that area are not that easy to set up and far from blazingly fast. But when all rendering and events processing is done on the server, we can run end-to-end tests without a browser at all. No Selenium, no Cypress, nothing like that. An excellent testing library, BUnit, enables developers to write tests on Blazor components, which work almost like a breeze. Well, I'm saying always because we still stumbled upon few problems while figuring out how to write tests in the most suitable way for us. But after we figuring it all, every developer is just writing this testing code in a very straightforward manner, including juniors. So, while quantitative harder, better, faster, stronger is important, it's rarely enough by itself. An architectural decision must turn something impossible into possible to really make a difference. I already mentioned that we keep all tenants' data in memory. That is convenient in many situations, but especially when processing user actions involves many steps, and the results of previous steps determine a working set of next steps. Without hot data in memory, processing such requests demands multiple round trips to a data storage. And when we step away from the relational data structure to a graph, this problem exaggerates. There are no fixed joins anymore, and everything potentially can be connected to everything. Why am I talking of graphs all of a sudden? We tried hard to fit our domain data structure into convenient and well-explored relational model, which I personally am a big fan of. I try to stick with relational data models as far as it possible. But we had to admit, it's not working for us. Graphs are much better at representing this complex reality of project and product management. But if we have a graph, then how to query it? There are many graph query languages, but we decided to design and implement our own query engine. This engine operates on top of our in-memory data storage. So, is it a complicated case of not invented syndrome? Well, at first glance you may think it is, but I believe it's not. We use this query language not just to retrieve data from a tenant's graph, but also to make non-trivial changes over the results. With complete control over what is possible and what is not with these queries, we can walk a very narrow line when queries are both powerful enough from a data retrieval perspective and still simple enough so we can automatically derive actions like create new item in that section of result, move that element from this section to another section, and so on. That may sound overly complex, but it enables us to build whole part of the product in a simple declarative manner. Just by defining data query and presentation rules, we are getting not only view functionality, but also update and create functionality for free, all of it with business logic and restrictions embedded. So, now back to possible impossible. Implementing this engine without all data readily available in memory would be too complicated for our limited resources. But with in-memory storage, statefulness, and zero efforts on cross-technology API design, it now falls within reach and allows us to be extra effective. And Blazor Server makes this stateful approach viable for our product. Before moving to the bad part, I want to share some synergies that emerged in development. These synergies are less related to Blazor directly, but are still interesting. And without Blazor and .NET, we would not even explore these areas. Also, I'm proud enough of them, so I want to share. One of the first questions that I had to solve was maintaining the consistency of the in-memory data state, concerning possible errors in the process when we do complex composite updates. We cannot afford the situation when part 1 of an update succeeds, then part two of the same update fails for any reason, could be validation, business restrictions, transient failures, anything like that. But the effect of the part 1 is still visible. When a state is kept in a traditional relational database, this is trivially achieved with transactions isolation and rollbacks. But when the state is kept in memory, this luxury is not readily available. I would be delighted to see STM, software transactional memory concept, to be adopted in .NET. That would allow to do something very similar to database transactions. But it is not here yet, and we have to be creative. Luckily, we have the power of ORM at our hands. After some fiddling with EF core, we built reliable rollbacks on top of it. As long as the composite update is performed in a single unit of work, it's possible to undo changes in the in-memory state. This is a very helpful trick to know when working with detached entities in ORM. But please be warned. The level of transactional isolation, if making some parallels with SQL Word, is not a familiar read committed. It's read uncommitted, because partial updates can still be visible by parallel processes. In case of errors, these updates will be rolled back, but they are still visible in the process. This is not a problem for our application, but it can be a crucial problem for some others. Okay, to the next point. Another interesting part was related to modeling data updates. In project management domain, updates themselves are just as crucial as the entities updated. It's important to track who and when changed what, not just for auditing or blaming purposes. History of changes is vital for retrospective analysis and searching for root causes of problems. It's also important for building reports. With that in mind, I decided to approach changes in data from an event sourcing perspective, with every kind of updates persisted in a suitable object. But there is a catch with event sourcing. It adds a considerable amount of mundane work required to keep event classes consistent with entities update classes. Changes in attributes of domain entities must be reflected in corresponding classes for update events, and it's easy to forget or mess up. To avoid this pitfall, we decided to take advantage of a relatively new C# feature, source generators. Source analyzers were part of C# for a long time, but .NET 5 added generators. Long story short, we managed to automatically generate corresponding update classes for domain entity classes. Any change in domain class is reflected in the pair update class without any effort from a developer. Effort-wise, it took me about 3 days of my time to implement from zero to working code. And the resulting code is simple enough, so junior developers can make improvements there without any problems, just with a minimal guidance. And the final point. While we maintain our query language, it's unwise to do every much in memory when we have a database with powerful indexes at our disposal. Memory is excellent when jumping from one object to another, and databases are great at filtering and sorting a huge number of rows. We want to make best use of them both. On the other hand, the last thing that we want is to expose this detail in the queries themselves. So, for our restricted set of query operators and sorters, we developed a translator into .NET expression trees. And then these trees are executed in a well-familiar way, either translated to SQL or compiled into IL and executed by .NET. What exactly will happen with query operators is completely opaque and determined by the simple optimizing matcher in the depths of our queries executor. Surprisingly enough, that trick took much more effort to implement than expected. Generating expression trees at runtime is full of pitfalls, and documentation is lacking in depth and details. Okay, with that tone set, we can move to the next part. Of course, it cannot be all ponies and sunshine. There are pitfalls to look up both from Blazor server itself and the induced stateful architecture. Stateful applications require much more careful planning for many quality attributes when compared to stateless ones. Also, mitigation strategies for many emergencies are far less trivial. With stateless applications, problems like memory leaks can be easily kept in control with measures as simple as regular restarts. You can just take your time in fixing this problem, while in production you just have a simple mitigation strategy. But this is not the case with stateful applications. Three quality attributes are particularly affected by this: resource consumption, fault tolerance, and scalability. The architect must answer how to handle each of them beforehand. Otherwise, it may be too late to implement an effective solution in time of need. Luckily for all, more complicated doesn't mean unsolvable. There are many approaches on how to tackle these problems with stateful applications. These are dangerous waters, but well-charted ones. Coming up with an effective solution will require an effort from an architect, but let's not dismiss the approach just because there are fewer blog posts about how to deploy stateful applications in Kubernetes. Pun intended. Another important thing is that Blazor itself is less mature than good old model view controller on top of ASP.NET. Nothing critical, but in some situations you will need to develop your own solution to problems already well solved in more traditional stacks. Few things where we stumbled. The detached mode in Entity Framework core is not without surprises. Change tracking can get complicated. Feature flags integration is non-existing. You have to develop something of your own. Cookies consent policies are far less trivial to integrate. And generally, everything related to HTTP context is non-intuitive. Please don't take me wrong. All of the problems above is one-time delays, not a persisting multiplicative slowdown factor for the development perspective. But please be warned. And from the business perspective, it's important to understand that these problems are all lies in a technical domain where expertise is widely available on the market. If your business model works well and people are storming your products and you have the scalability problems, it's easy to find some super guru expert who will help you to solve the problem, and you will probably have enough money to make it. But there are no people available on market that will solve your business problems. So if you're making a decision where to shift these complexities to business domain or to technical domain, for me the answer is always move it to technical domain. It's easier to solve, and maybe you will not even need to solve it. And the last point. There are very few developers with existing Blazor experience at that moment. And it's especially hard for startups. Big enterprises can just pull a big pile of money and snatch another person from another company, but it's not an option for most startups. That was not a blocker for us. because we started with education program with junior developers, and it worked good enough to bring new hires up to speed. But team scaling strategies are very different for different businesses, so be warned. This will likely change in the future, and maybe even in a year or 2 or 3, but right now this is a risk factor that you must consider if you're choosing Blazor to be your foundation for the product. Thank you for your time. I am open for your questions about anything regarding Blazor server and stateful applications, or our product if you're interested right now, or you can find me later on LinkedIn or Telegram. I'm also an active member of International Software Architect Club. You can find me there. So, thank you again for your time.